viewers. In today's lesson, we'll be discussing testing of statistical hypothesis. Testing of statistical hypothesis. If you're new to this channel, kindly make sure you subscribe, you like, and share the videos with your colleagues who are also going to find it helpful. So without wasting much of our time, let's go into the work in this lesson. Testing statistical hypothesis. Testing statistical hypothesis. Testing statistical hypothesis. So in this aspect, what we're trying to do is that we want to test hypothesis. That is, we want to know if hypotheses are true or if they are actually false. If they are true or if they are actually false. And in this situation, we will be dealing with two basic hypotheses. The first one, which is the null hypothesis, and the second, which is the what? Alternative hypothesis. So in this case, your null hypothesis is denoted as H naught, while your alternative hypothesis is denoted as H1. And I also want to take note that in this situation we focus more on null hypothesis. So we can either reject our null hypothesis or we accept our null hypothesis. And you should know that once the null hypothesis is rejected, it automatically means that the alternative hypothesis is accepted. And if the null hypothesis is accepted, it means that your alternative hypothesis is rejected. So while having our test of hypothesis, errors might occur. So in test of particular hypothesis, we basically have two types of error. So the first type of error is known as the type 1 error. We have the type 1 error, and the type 1 error is also known as the false positive. It's known as the false positive, and we also have the type 2 error, which is also known as the false negative. The type 2 error is also known as the false negative. So the type 1 error is a situation whereby the null hypothesis is rejected when it is actually true. So if your null hypothesis is true, but you end up rejecting it, then the type 1 error has occurred. If the null hypothesis is accepted when it is actually false, that is, you accept your null hypothesis, but in real sense the null hypothesis is actually false, then a type 2 error has occurred. So we also have the concept which we know as level of significance. And in most cases, we always make use of 5% level of significance, which is known as alpha. So the opposite of your level of significance is known as your level of confidence. So let's say your level of significance is 5%. Definitely your level of confidence will be 100 minus 5, which is 95%. So we always, in most cases, we work with 5% level of significance, which actually means that your hypothesis should be wrong only 5 times in 100 situations. It will only be wrong 5 times in 100 situations. It means that your level of confidence is 95%. That is, you are 95% sure of your test of hypothesis. So under this aspect, we'll be dealing with 3 types of tests. The first test we should be dealing with is known as z-test, and the second type of test is known as the t-test, and we also have the chi-square. Although we also have one type of test as well, but we can't classify it under test of hypothesis. That actually involves test of mean, which is what analysis of failures. Analysis of failures where we test the qualities of means. So that's also a test under statistics, but we won't be discussing it in this lesson. We'll be discussing it in a separate lesson. And we will be discussing these three types of tests, in which we will be discussing two of them, that is z-test and t-test, in this particular lesson, and we'll be discussing chi-square in the next lesson. So without wasting much of our time, let's move into the first test, which is what? Which is z-test. And you should also take note that in any of these three types of tests, you'll be given a critical value. That is the critical value of z or t or chi-square in which you want to work with. And if you are not given those critical values, you'll be given parameters in which you use to find those critical values in your statistical table. But in most cases, you always be given critical value of those z, t, and chi-square. So the formula in which you use under z-test, which is z is equals to what? Is equals to x bar minus mu naught, and mu naught represent what? The null hypothesis. The null hypothesis divided by sigma over square root of n, where x bar is equal to your average and mu naught is equal to your what? Your null hypothesis. Your sigma is equal to standard deviation and n is equal to the number of population as usual. Your n is equal to number of population, population. Then you give the critical value of z. So you give, it can be anything. And after calculating your z, you now check, you compare with your critical value whether you are going to be accepting the null hypothesis or rejecting the null hypothesis. So let's say, for example, after calculating your z, you draw your distribution and your critical value of z happens to fall within this region. This is your critical rate, z critical. Any and if you calculate your z, if your value of z falls within this region, then you reject the null hypothesis. But if it doesn't fall within this region, that is, if it is less than the critical value, and this is positive, the way when the critical value is positive, if it doesn't fall within this region, that is, if it is less than this, then you accept it. But let's say your critical value is negative, when your critical value is negative, you have this region, and your z calculated fall to this region, you also reject null hypothesis. As well. So without wasting much of our time, let's move into the first example. Example 1. This example says, suppose that 100 tires of a certain brand lasted on the average of 21,000 for 31 miles. That's the given the average, which is x bar. X bar equals to what? 21,000 laps. With a standard deviation of 1,295, sigma, that's sigma, 1,295 miles. Using a level of significance of 0.05, that's 5%. 5 divided by 100, that's 0.05. So we are giving that level of significance, which we not even using in this aspect because it is not involved in the formula. So you are told that test a null hypothesis. The null hypothesis. If given null hypothesis, that will be mu naught. Could be what? 22,000 marks. Against an alternative hypothesis that mu is less than 20,000 marks. And we are given critical value z-critical to be equal to what? Minus 1.645. Minus 1.645. Minus 1.645. So solution to this. So your null hypothesis H naught is given as what? As mu naught equal to 22,000. And your sigma, which is given as 1,000, 2,000, and your alternative hypothesis H1, we've written all the parameters as well. I don't want to repeat it here. Your H1, which is your alternative hypothesis, says mu is less than 22,000 marks. 20,000, we have given x bar, and we have our mu naught. So we can now introduce our formula. N, number of population. N is given as what? Given as 100 because of the first statement to test 100 times. 100 times. So N is given as 100. So applying our formula. Z, which is equal to x bar minus mu naught over standard deviation divided by square root of n will definitely be equal to x bar. X bar is 21,431 minus mu naught, which is what? 22,000. Divided by standard deviation, and our standard deviation is 1,295 divided by square root of 100, which are n. So if you complete this ratio, you should be getting minus 4.39. You're getting minus 4.39. So we are able to calculate our z. So we can now draw or plot the distribution. So by plotting the distribution, as you can see, your critical value, you plot your distribution with your critical value. The critical value you're giving is what? Is a negative, minus 1.645. So it will be in this side. So the distribution is symmetrical. So your critical value will be around here, which is minus 1.645. Minus 1.645. Critical value minus 1.645. So let's say, anything that falls within this critical value here, it will be what? It will be rejected. So let's say, does this fall within this? Minus 4.39 is less than minus 6.45. Don't forget it is a negative. So it is less than this is less than this. So automatically this will fall within this region. It will fall within this region. So since Z is less than, Z is less than Z critical. Z is less than Z critical. The null hypothesis is rejected. The null hypothesis is rejected. So the null hypothesis says mu naught is equal to what? 22,000, and it is rejected. Automatically we accept the organic hypothesis. That means that what? Mu is less than 22,000. That is, mu is less than 22,000. It is as simple as that. So moving to the next example, the next test, which is your t-test. Moving to the next example, which is our t-test. And mind you, we make use of our z-test. We make use of z-test. when n z-test, we make use of z-test when n is greater than or equal to 30. When n is greater than or equal to 30, that's when you make use of what? Of z-test. But we make use of t-test, it is used when n is less than 30. So anytime n is less than 30, you make use of what? You make use of t-test. So in most questions, in some questions, you might be told the kind of test you are to use. But if you are not given the kind of test you want to use in the question, so you check your n. Is it greater than or equal to 30? If it is greater than or equal to 30, you make use of z-test. And if it is less than 30, you make use of what? Your t-test. So your t-test, in t-test, t, the formula is given as t equals to x bar minus mu naught over s divided by square root of n. S in this situation is also your standard deviation. But in t-test, we represent standard deviation with s and not sigma. Please take note, where x bar is equals to the mean or average x bar is equals to mean or average, and mu naught is equals to the what? Null hypothesis. S is equals to the standard deviation, and n is equals to what? Is equals to number of population as usual. And we also given the critical value of t, like I have said before. And if you are not given the critical value of t, you will be given parameters in which you can use to determine the critical value of t from your statistical view, from your t-test. So let's solve an example of t-test. Example 1. Let's solve an example on t-test. So this example says, suppose that the specification for a certain kind of ribbon cell for a mean breaking strength of 185 pounds, and that 5 pieces randomly selected from different rows have a mean breaking strength of 183.1 pounds with standard deviation of 8.2. Assuming that we can look upon the data as random for a normal population, test the null hypothesis mu equals to 185 against the value hypothesis mu less than 185 at level of significance alpha equals to 0.05. Take critical value t to be what? To be minus 2.132. So it's very clear that we should take our null hypothesis as what? 185. That's the mu naught. So your mu naught will be equal to what? 185. And it says 5 pieces are randomly selected. So let's automatically your n is equal to 5. And the question also says that a standard deviation is equal to pounds. S. Don't forget, in t-test, we make use of S as our standard deviation. S is equal to 8.2 pounds. And it also says that our mean breaking strength of 183.1. We are giving 2 mean breaking strengths, and we already said we should regard 185 as our null hypothesis. Automatically, the second mean breaking strength will be the average, that is S bar, which is equal to 183.1. So, solution to this question, it says that your null hypothesis H naught should be equal to what? 185. Your alternative hypothesis H1 should be guided as mu less than 185. Less than what? 185. Is it given in the question less than 185? and we already know n to be 5. All the parameters there that has been given, I've stated everything out. So let's apply our formula t. We call our formula t equals to what? Is equals to x bar minus mu naught over s divided by square root of 100, which is equals to x bar is given as what? 183.1 minus mu naught, which is your null hypothesis 185, divided by s, which is 8.2 is our derivation, divided by square root of what? Of 100. Square root of 100. So if you compute that very well, compute that correctly, you should be having minus 0.49. Minus 0.49. So calculate our t. So we can now what? We can now plot our distribution to determine if that hypothesis will be accepted or rejected. So if you plot, and now you are given a critical value. Don't forget the critical value given, which is t critical. You know you are plotting the distribution with a critical value. T critical is given is what? Minus 2.132. You are given the critical value as minus 2.132. So plotting your distribution, you know, minus that's the negative. It will be falling to this side and not this side. So and minus 2.132 should be around here. Minus 2.132 minus 2.132 minus 2.132. That's the critical value. So anything that falls within this region will be what? Will be rejected as usual. So let's check. Does it fall within that region? Does it fall within that region? Does it fall within that region? This is minus 2.13. Or minus 0.49 is greater than minus 2.13 because this is 0. Before you get to minus 2.1, this is 0 here. Before you can get to minus 2.13, you pass through minus 0.49. And 0.49 will be within this region. Will be within this region. So automatically it doesn't fall within this range. So since t calculated is greater than the critical t. Is t calculated is greater than critical t, that is minus 0.49 is greater than minus 2.13, the null hypothesis. You know, you reject everything in this range. You reject. But everything in this range is what? Is accepted. So everything in this range is accepted. Since null hypothesis, since this is greater than this, the null hypothesis is accepted. You accept it. Is accepted. Is accepted. That is, we said the null hypothesis should be that this is equal to this. That is, will not is equal to what? Is equal to 185. That is, the mean tensile strength is equal to 185. Is equal to 185. So that's the final conclusion to that, and that problem will bring us to the end of this lesson. So in the next lesson, we will be discussing about the last type of test of hypothesis. So if you're new to this, which is Skype, if you're new to this channel, kindly make sure you subscribe, you like, and share the videos with your colleagues who are also found it helpful. Tutor Bosun is here. Thank you.